some or most or all of their estrogen receptors. Somebody talk to me quickly. It would slow the growth of the tumor. Y'all with me on this? The problem is that every medicine has its side effects, and tamoxifen is toxic to your body. They actually have some women who are at high risk for breast cancer to take tamoxifen prophylactically. Do you know what I mean by that? They want you to take it long before you're ever diagnosed with cancer, so that if you got some cancer, maybe it would help it grow slow. You got it? Now, there's about 10 other kinds of breast cancer. There's ER negative, there's PR positive and negative, there's HER2 positive, and so forth. But 95% of it is an ER positive tumor. Now, I'm getting to the soy question. Are you still with me? Because the women in America have heard that soy is bad, and there's two reasons. They may not know either reason, they just heard it's bad. So plants, all plants, make chemicals. They make the nutrients that you and I eat, but they make other chemicals besides. And scientists have slowly learned what these are, and they have learned that soy makes estrogen-like chemicals. They actually call them phytoestrogens. That means phyto means plant. So these came from a plant, and because of poor, how should I describe this? People were jumping to conclusions, and they assumed that the phytoestrogens, a proper term if you have a technical background, is phytosterols. But some of those are estrogen-like compounds. They assumed that those soy phytoestrogens would also make the tumor grow fast. And so don't eat soy, ladies. Y'all with me? Pardon? I don't understand when you say especially the men. Oh, some people were saying men shouldn't eat it because it would make them a little bit more effeminate because of the estrogens. Is that kind of what you're saying? Which, of course, is completely false. The interesting thing that has been learned is actually the soy phytosterols, the soy estrogens, actually make the tumor grow slower. Would you please write that down somewhere? Y'all with me? If some of you are technical background, I can give you a 2-page summary of all the research that's been done that shows these kinds of things. The other reason that Americans have learned, I hate the term because it's bad learning, that soy is bad for you, is because about 97% of the soy that's raised in the world is from a genetically modified seed. And I really need almost an hour. Now, let me just tell you this. A couple of them were my former professors from graduate school. How many of you know the name Neil Nedley? Is that name known? Not many. If you watch 3ABN, you'll eventually see Neil Nedley. And when he is on, they get the most emails and calls in with questions than any other person that ever gets on 3ABN. Dr. Neil Nedley. He's the current president at Weimar. I think I told you when he first became the president 11 years ago, he couldn't be there because he was practicing in Oklahoma. Weimar's in California. He called me up and asked me to be the administrator for 2 years. You remember that story? All right. So I know this man very well. I have incredible respect for his knowledge. So he's one of the 6 people that I called. I called Dr. Ken Burke, he has a PhD in food science. If you want to ask somebody that would be an expert on that question, it would be somebody that has a graduate degree in food science. I called the medical director at Weimar, Clarence Ng, a physician who's been at this work for many, many years. I called 2 or 3 other people. They all said the same thing. I will quote to you the exact words that Neil Nedley used. This is what he said now. This is about whether or not genetically modified food would be harmful for you. Are you all with me on this? This is what he said. He said, Jim, I don't think it is, and I don't think it ever will be. Now, I just wanted to be sure that what I thought was correct, and I gave the lecture, and I explained why. I could tell you why in 3 or 4 sentences, but it probably wouldn't make any sense at all, but I'm going to do it anyway. If you understand that a gene codes for a protein, y'all with me? And if you take, I'm going to give you a story first. The very first genetically modified organism that was ever done was a E. coli bacteria. And the ladder in the E. coli is actually a circle. For the sake of simplicity, I'm going to draw it straight. Y'all with me in what I'm drawing? I'm drawing the DNA, correct? The scientists actually cut the DNA. If I had a different color of chalk, pretend it's a different color. And they put in here, I'm going to use crooked lines to represent this. They're straight, but they put the gene in there for insulin. They took a human insulin gene from somebody's DNA. Are y'all with me? Every cell in your body has DNA, is that correct? Except the red blood cells. And in every one of those DNA ladders, there is one of the many genes is the gene that codes for insulin. Are y'all with me? Insulin is a protein. They took a human gene and stuck it in there. And you know what that bug started making? A bug, I'm calling it a bug. It's a microorganism, correct? You know what it started making? Insulin. It now has a gene that codes for insulin. So what is it going to make? Insulin. Now, starting, don't hold me to this date, this is pretty close. I think it was 1924 that scientists finally figured out if they would grind up the pancreas of a cow or a pig, they could keep a child alive that had type 1 diabetes by trying to get the insulin out of that pancreas and purifying it a bit and injecting it into the child. Y'all with me on this? Up till that time, these children died a horrible death. Until 1978, all those years, all the insulin that your forefathers took, maybe none of you in this room started taking insulin before before 1983. I'll tell you why it's different. All of that insulin came from grinding up cow pancreas or pig pancreases and trying to purify the insulin. This little girl is going like this. So, however, so the scientists put in 1978, they did this, and they took the insulin and tested it on rats, then they tested it on people, and finally the Food and Drug Administration in the United States, which is where this research was done, approved the use of this artificial insulin. Although it's exactly the same as human insulin because it uses the gene that codes for insulin. Y'all with me on this? Go ahead.
Why is an E. coli?
What? Say it again.
Why was an E. coli cell used? Or
I'm not getting your word.
you said it was in E. coli?
People?
E. coli, the cell. The cell.
Oh, E. coli. They could have taken any organism and put that gene in there, and the organism would start making insulin. But because we have known more about E. coli than anything else even close, they took something that they knew the most about. Good question. Never had it asked before, but it's an interesting question. So all the insulin now, folks, no exception to this, is made by E. coli bugs. They put them in a great big vat, thousands of gallons. They feed them all the sugar they want, and when they open the faucet, what comes out? Insulin. And the scientists have gotten tricky. They have taken that gene and just changed one rung to a different rung, and lo and behold, the protein, insulin, now has a slightly different shape. Y'all with me? And it lasts longer. Have any of you ever heard of long-lasting insulin? And short-acting and so forth. So scientists have played with the ladder rungs and made different kinds of insulin that sort of help them with patients' control. Now, if you followed all of that, here's the bottom line. The only thing that's different about that plant that had some genetic modification, follow me now, friends, is that it is now making a protein that it did not make before. What did we put in that plant that wasn't there before? A new gene. Genes code for proteins. Come on. Are you with me? So the plant is making a protein it didn't make before. And when that protein gets into my tummy, what happens to it? It gets unfolded. Does that sound familiar? All protein, folks. Doesn't matter where it comes from. When it gets into the hydrochloric acid, that special shape is unfolded. Y'all with me? And now you have a chain of amino acids, right? Which get cut up in the small intestine. Those amino acids go to all your cells so they can make the proteins that they want to make. Did you get that? Does it make sense why Dr. Nedley would have said, Jim, I don't think it's a problem. I don't think it ever will be. Are y'all with me on that? Okay. I'm going to ask you questions about it tomorrow night.
Okay, we know very well that a lot of GMO foods are not being exported to Europe. Is it that the European scientists are not knowledgeable about this, or do they have a different study?
Good question. Europe was quite quick to get on the bandwagon against GMO.